Okay, today we're going to pick up from the seventh grade work from, I think the video was number 5. Well, it had surface area and it had one more thing on it. It had surface area and volume that we want to talk about right now. So we'll talk about surface area first. So usually when we talk about this topic in 7th grade, people have a hard time understanding exactly what that means. So surface means kind of on the top, like this is the surface of this board. The back of the board is against the wall, so we wouldn't call that the surface. This where the pens are, the markers are, is the surface of the chalk tray or the marker tray. This is the underside. So when you eat lunch, dinner, or breakfast, you eat on the surface of the table, not under the table. So under the table will be considered the bottom. So the surface area, we know area means space. The space inside is area. So let me just write that as a reminder. So area is the space. I know this is going to show up where that light is. Space inside of a shape. It could be the circles. The area is the space inside of a circle. It could be a triangle. The space inside the triangle is area. It could be any polygon, which means multiple-sided figure. So this would be the area. Now, just as a quick review, since we have this, a circle, the area is inside of all of these, but the distance around the circle, you know, is circumference, which I'm going to just say C. The distance around this triangle, this three-sided figure, because tri means 3, is perimeter. So this is a triangle because tri means 3. This is a quadrilateral. The distance around the quadrilateral is also the perimeter, but quad, Q-U-A-D, means 4. So quadrilateral, quad, Q-U-A-D, R-I lateral, T-E-R-A-L. See, lateral means sides, and quad means 4. So triangle, A-N-G-L-E, means 3 angles. 1, 2, 3. So the word triangle tells you the shape. Quadrilateral is a 4-sided figure, lateral meaning sides. I may have spelled this wrong. It may be Q-U-A-D-R-A, but I think that's right. So you can fix it if it's wrong. So surface means top, or we'll see that it generally means top. It means top generally, like a kitchen table. But in the problems that they want all the sides, the top of every side. I'll show you that in a minute. Every side. So let's take a actual example. What if we had this box? And the problem that is stated on Study Island or tests we make up will say, find the surface area of this box. So what we're talking about is all of the area of this space where I'm rubbing, this side, this side, the bottom, and finally this side. So we have how many sides? One on the top, one on the bottom, and they're the same. One that you would call the front right here, the back, and the two ends. So we have 1, 2, 3, 4, 5, 6 sides. So we have 6 sides. But in the box, you will often see the diagram in your problem that doesn't have the 6 sides. I'll show you what it has instead. It's almost as if they took the box apart like I'm doing here, which you'll see it once we get it. They take the box apart. This tape is on here. It's not that strong, so it's going to come loose really nice. Maybe I spoke too fast. So now they will take that box, and it won't look like a box to you once they get finished. You see, they'll take the box like this, open it up, take this side loose right here. So now they have this whole box that they will put in a diagram for you, which we're going to do also. And I'm going to take a piece of tape, which you'll see. We'll take a piece of tape and put the box up on the board so we can see how the problem will be presented to you. So instead of having that box like we just had it, they'll make it look like this. But the problem is not going to be difficult. It's just a little bit tricky to see it, but once you see it, it's like nothing. So you're going to see a problem that in your mind you imagine it as a box, but the way it's shown to you, it's going to look different. But there's the whole box. I'm going to tape this down too, just so it'll be, so we can go through exactly what you're going to do if you, not if, but when you run across a problem like this, because that's, you're definitely going to see. And then I'm going to show you here exactly what to do with this one. So you'll follow the same pattern when you run across one that's actual. I didn't put that really nice enough to stay. So here's what you will do. And you'll see that it's not going to be that difficult. Okay, so now I'm going to take a marker and show you exactly how you will do these problems. I don't know what I did with the marker, but anyway. So you're going to just count up. I have 1, 2, 3, 4, 5, 6. So I'm going to just label these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So to get the total surface area of that box, all the parts that they might show me, I'll get the area of each one, and then I'll get the total number and then add them together. Now, since a lot of them are actually the same dimensions, it's going to be easier once you get the hang of it. So you'll see that a lot of the shapes, the pieces are the same size. Like whatever this is, 5 is that, 4 is that. So it's not going to be different. We'll just add them, and whatever 3 is, it's the same as 1. 2 might be a little bit smaller. But let's pretend like they're all going to be the same. But 2, 5, 8, and 11 might be a little bit thinner than 12 and 10. But for right now, we're going to pretend like they were the same and not actually different. So now, what do we do if we have a rectangle? The question is, since we have a rectangle, the area, I'm going to ask you to write this down later too. The area of a rectangle is length times width. And we usually say, even though we have 2 different dimensions, we usually, just for custom and convenience, we say that the longest side is the one we will call the length. So our length here would be what I'm pointing to now. So I'm going to color that blue. See, blue would be my length here, because this is longer than this other side, which is shorter. So I'm going to make that red. So I will call this the width and call this the length. And the same will be true across here too. So let's say for my figure I have 11 parts, right? 12 parts. And I can see that the length of 1 is shorter than 4. And the length of 7 is shorter than 10. So in order to make my box, I'm going to color code the ones that are the same dimensions, because they make the box symmetrical or even when I have it in one piece. So I'm going to color by red. This 1 and 7 are the same. 9 and 3 are going to be the same, because when the box is together, those are the tops and bottoms or the sides. So I'm going to make in green 2. When the box was together, 2 was the same as 8. And 6, we'll do it this way, 6 was the same as 12. I hope you're seeing this okay. And then 5 and 11 were the same. I'm going to do it this way. 5 and 11 were the same. So that's how my box got to be in the shape of a box. And then 4 and 10 were the same as, they're actually the same as 6 and 12, because those will be the 2 other sides, or the top and the bottom, depending on how it. So area is length times width. So let's say this length is 12 inches. Let's just say that, 12 inches. And let's say the width here is 6 inches. And you remember the 2 little marks mean inches, and the 1 mark would mean feet. So this is going to be, so this, see, if this is 12 inches, you know this is 12 inches, and they're all 12 inches. This is a little longer, so let's say this is, it's not staying down like I want. Let's say this is, this length is 18 inches. So 2 is 12, 12, 6. 1 I'm going to say is 12 and 6 inches, even though it's bigger than that, I think. But that's okay. This is 18 inches. 18, length is 18. The width is still 6 because it's the same as this. This is going to be 12 inches, 6 inches. This is going to be 18 inches and 6 inches. So my box is 6 inches tall. That's what we're saying. Now it's actually bigger than that. When we actually fold it together, it was bigger than that, but I'm using the 6 inches just for our convenience right now. So we can go through the process of figuring it out. And it's not accurate exactly. Now what we're doing now, we're kind of guessing at this. And we're saying to ourselves, we're not going to rely on what we see as much as what we say artificially. They do this for you on the diagrams they give too. If it's not meant to be exactly like it measures, they tell you, they give you a little thing, they say, drawing is not to scale. That tells you that you can't just decide by looking at the figure, because the figure is just an example. It's not meant to be perfect in the dimensions. So now we're going to talk about what would you do if you had this problem. Now you have to figure out the area of this, and add them together. That's all. And that becomes, once you do that, you have the total surface area. So 12 times 6 is 72. So I'm going to lay this out the way I would suggest that you do it. So you have area 1, 2, 3, 4. A lot of them are going to be the same. 5, 6, 7, 8, 9, 10, 11, and 12. Now you don't have to figure them all out, remember, because a lot of them are the same. So, area is length times width. So I'm going through this very slow and methodical so you will be able to follow it. There's my formula. I'm using that formula for every one of these, even though I won't have to do it for every one because a lot of them are going to be the same. So let's say I do number 1. 6 times 12 is 72. So length times width for number 1, length times width equals 72 square. Remember, area is in square measures. So I say number 1 is 72 square inches. So I would check off number 1. I did that. But number 1 is the same as number 7. So I go to 7 right now and say 72 square inches, because I know 1 and 7 are the same. I know 1 and 3 are the same. So I go to 3, 72 square inches. 3 is this, so I check off 3. I check off 7. I can check off 9 because it's the same. So 9 is 72 square inches. See, if they're not the same, I wouldn't have a box. If you have a box, the only reason that you can make a box is because the dimensions are the same across from each other or parallel. So now, we said that number 2 is 12 times 6. That's 72 also. So number 2 is 72. See how easy this is because we're using the same dimensions repeatedly. Number 2 is 72. 2 is the same as 8. So 8 is 72. So we got a lot of 72s because that's the way we decided to do it. Now, we don't have any more 72s. We've done 1, 2, 3, 7, 8, 9. Because, see, those will be across from each other. They'll be the two ends of this boxes, the front, the back, and the two sides. I can see that. So we have that. So now this is 6 times 18. Number 4 is length times width equals 6 times 18. So we have to figure out what is 6 times 18. So we'll just multiply it and see. I'll do it on the side. You can do it also, but we'll do it together right here. So 6 times 18. So I have 18, 6. 6 times 8 is 48. Carry my 4. 6 times 1 is 6, and that's 108 square inches for number 4. So number 4 is going to be that, 5 is going to be that, 6 is going to be that. So they're all going to be the same, because we assumed that this was the same length, the width, but it might have been more, but we're just going to do this way for now. So this was 108. So 108 square inches. So 4, 5, and 6 is 108. I'm going to skip the length times width and just say 108 square inches. Square inches. So 4, 5, and 6 are done. Now we know that 4 and 10 are the same, 5 and 11 are the same, 6 and 12 are the same. So I can put 108 for all of these. 108, 108, 108 square inches. Square inch, square inch. So now I have all 12 of my pieces, and I can now take this down because I have all the dimensions, so I don't really need this anymore. So I'll take this off, and our demonstration will be finished. And if we want, we can put our box back together, or we can store it for another example later. So we can put that to the side. Then we just simply have to add these up. So we will do that. So I have, let's see, how many 72s do we have? 1, 2, 3, 4, 5, 6. So rather than me adding 72, 72, 72, I know you figured out that we could just say 72 times 6 will tell us what all those would add up to. So 6 times 2 is 12. Carry my 1. 6 times 7 is 42, and 1 is 43. So that's 432 square inches for 1, 2, 3, 7, 8, 9. So we do the same thing with the 108. It's going to be how many 108s? That we pretty much know. It's going to be 6 more because we had 12 sides. So we got 108. That's 1, 2, 3, 4, 5, 6. Now, of course, we could just add up 108 plus 108 plus 108 plus 108, or we could say, Dr. Whitaker, let's make this easier for us. 108 times 6. So 6 times 8 is 48. Since I had a 0 there, I can just put down the 48, and 6 times 1 is 6. 648 square inches. So my total surface area is going to be 432 plus 648. So I just do that. So I have 648 plus 432 plus 2 and 8 is 10. Carry my 1. 5 and 3 is 8. 6 and 4 is 10. So the total surface area is 1,080 square inches. Problem solved. So we say, okay, that's good. We did a good job. So that's the total surface area. Total surface, we messed this up with our box, surface area. And we used, the key to this was we used the formula area equals length times width. Now this is important. So you take some time, write this down and make sure you understand it because we need it for other things going forward. So the next video we're going to do, which I'm going to do right now, this will be number 6 for this. And then we'll have number 7 to go to the volume. So there's 2 things I want to discuss about volume. So we'll have that. Now, I don't expect you to get this perfectly all at one time, but you'll have the tape so you can review it. And once you get some problems, you'll begin to see, oh, okay, I got it. It's just this. It's just that. So you'll get it. So I'm going to stop this, clean off the board, then we'll go to volume.